Hey guys, welcome back. We're going to continue talking about Unit 1.2, Chemistry in Living Systems. But today we're going to move on and talk about the different properties of water. So water is an essential molecule. It is something that all life needs in order to survive. So we're going to talk a little bit about some of the properties of it that make it so amazing. And then we'll go on from there, all right? All right, let's get going then, huh? So the first thing to note is that water is the most abundant compound in the biosphere. Now, water, as we already said, is essential for life. And you might have heard of like places suffering from drought and all of that. Remember, water being made of matter can actually come in different phases. So when they talk about there being a drought, they mean that clean, fresh water is lacking. It's not as easy to find. But there can still be salt water, like in the oceans. There can be water vapor in the air. There can be ice. There can be water under the ground. So there is a lot of water all around us. It's just not always in a usable form. And that usable form is generally as fresh water. The chemical formula, as you can see for water, is H2O. What this means, you see a little 2 as a superscript behind the hydrogen. That means that there are two hydrogen, which are these white balls right there and right there. And the two hydrogen are connected to one oxygen atom. So let's talk a little bit about water polarity. Now this goes back to what we were talking about in our previous lesson about the van der Waals forces, the intermolecular forces of attraction. So because water is a polar molecule, that means that it has one side that is partially positive, and that's going to be on the hydrogen atoms, and one side that is partially negative, when that will be on the oxygen atom. So when we see that partial negative on one side, partial positive on another, we call that being polar. And that's just simply because, as you can see in the picture down here, the little tiny circles like those are the electrons. And they tend to be grouped more densely around the oxygen, which is why the oxygen has a slightly negative charge. Whereas the two hydrogen, there are no electrons on the outer edges. So the closest thing to the outside would be the nucleus, and that contains the positive proton. So that's why they have a more positive charge. Polar molecules are molecules that have partial positive and negative charges due to the unequal sharing of electrons. So we generally see this with covalently bonded molecules, specifically when different elements are bonded to each other. You won't necessarily see, like if it's oxygen gas, you may not see it as much. But when you have two different elements, they cannot share the electrons equally. So we end up with these partial negative and positive sections leading to polarity. All right. So this is kind of like some of what I was drawing in the van der Waals forces video and what I've tried to show you before. So we have the partial positive on the hydrogen being attracted to the partial negative on the oxygen, and these are from two completely separate water molecules. Now this slight attraction is strong enough to form a bond. We call this a hydrogen bond because it is from one hydrogen to another atom. And these hydrogen bonds, they're formed between, in terms of water, between the hydrogen atom of one water molecule, like you can see here, and the oxygen molecule of another water molecule. Now, as you can see again from the picture, each water molecule can have up to 4 hydrogen bonds, one from one hydrogen, one from another, and then there can be 2 on the oxygen from other water molecules. So they can each form up to 4 hydrogen bonds. And it's this idea of the hydrogen bonds due to polarity that will allow for all these properties we're about to discuss. So the first property we're going to discuss is cohesion. Now, cohesion is essentially when the hydrogen bonds between the water molecules cause them to stick together. As you can see with this picture here, the dew, how it makes these droplets. Now, it's not like the dew, which is just water that's condensed on the leaf, slides and will spread out right away. It actually causes these water bubbles at first. What that is, it's the actual water molecules being stuck together due to the hydrogen bonds between them. So again, we call this cohesion, when water molecule sticks to water molecule. So they're stuck together. Now, hydrogen bonds are very weak compared to ionic bonding and covalent bonding. They're strong enough at this point, but if more water was added to that, then gravity takes over and will pull it, and then that's when it starts finally being pulled down the leaf. Also here, cohesion is the cause of what we call surface tension. This is a bug walking on water. You can see how its feet are kind of pushing down on the surface of the water, but not going through it. That's because, again, of the cohesion between the water molecules. It's bending the molecules down, and that allows for the insect to walk on top. It's not heavy enough that gravity pulls it through the water, and it just kind of stays on top of the water because these hydrogen bonds, they don't want to separate. But if you push down, or if that bug was a little heavier, then the weight of it would cause those hydrogen bonds to break, and the bug will now go through the water and will no longer be sitting on top. So the idea of surface tension is caused by cohesion. And again, that's just the water molecules being stuck together and not wanting to separate. That's why when you also do a belly flop, why it hurts so bad. Because you have this broad surface of your body that smack the surface of the water, and what you're feeling, why it hurts, is because you hit the water and all of those hydrogen bonds, they don't want to separate. So for a moment it feels solid, but then the force of you falling onto the water causes them to separate, and now you sink in. Adhesion is very similar to cohesion, except remember, cohesion is when water molecules form hydrogen bonds between each other and stick together. Well, adhesion is when water forms hydrogen bonds with other molecules and sticks to them. So it's the same idea. Partial charges on the water molecule can attract the electrons in other polar compounds. And since we still have that attraction between positive and negative, we'll still get those hydrogen bonds forming. Again, it's not that they're forming true bonds like a covalent bond. Hydrogen bonds are weak, but it does add a layer of stickiness to the water because the water can stick to things due to these hydrogen bonds. Like we see with the dog and that poor unfortunate child. So when they get wet, whether it's by the rain or a sprinkler or a pool or a bath, you get wet, the water sticks to you. Now, yes, you can take a towel and you can rub the water off. But what's going on is when you get wet, maybe you just went for a swim, you know, it's summer now, but when you get wet, the water sticks to you. It forms hydrogen bonds between the water molecules and your skin. That's why when you get out of the water, yes, you drip for a little while, but even after that, you still maintain a thin layer of water on you because it's stuck to you thanks to hydrogen bonding. When I take a towel and I dry myself off, I'm essentially using that towel to enact a force and break the hydrogen bonds, which is why I can dry my skin off. But if you notice, it does tend to be more complicated with hair. And that's because in one strand of hair, the water is going to be hydrogen bonded all around it. And when we take a towel and try and dry our hair, we're not getting necessarily 360 degrees around the hair. So that's why your hair tends to stay damp longer than your skin does, because it's hard to get every single bit of water out of your hair just by using a towel, unless you want to go individually, which ain't no one got time for that. Adhesion also explains what's called a meniscus. So if you look at water in a test tube or a graduated cylinder like this picture here, what's going on is you'll notice this curve. So as opposed to the water kind of showing that bubble like we saw with the dew on a previous slide, it actually looks like it's pushed down and coming up on the sides. Now, this meniscus, when you want to measure it in terms of how much volume of water is there in this graduated cylinder, you always read it from the bottom, because the reason why it's pulled up like that on the edges is because of adhesion. The water is simply stuck to the sides of the graduated cylinder. So it's not actually going up that high in terms of the volume. The volume is down here at the bottom. But some of the water is just simply stuck due to hydrogen bonds between the actual water molecules and the graduated cylinder. All right, let's talk a little bit about solvents and solutions. So its polarity, the polarity of water molecules, makes it an amazing solvent. We actually do call water the universal solvent, because given enough time, it will break down just about anything. You even notice how ships that have sunk in the ocean, over time, they start breaking down because the water is actually dissolving the ships. And again, it's all due to this polarity. All of this is due to polarity, because polarity is what allows for the hydrogen bonds to form. So you have a solution. Now, all a solution is a mixture of two things. So you can have what we call the solute, which are the molecules that are being dissolved, and the liquid, which we call the solvents. So if I took a glass of water, let's say in this picture here, and put some sugar in it and mix it up, I dissolve the sugar into the water. The sugar is the solute. I am adding that to the water with the purpose of dissolving it into my liquid water. The water is the solvent. I am using the water to dissolve the solute. And together I have a solution, which is sugar water. Now what happens is, as you can see in this picture down here, the water molecules kind of form these bonds around the different sugar molecules, and then they just kind of float around and float away. Because what's going on is the partial charges on the water molecules are being attracted and forming hydrogen bonds with partial charges on the sugar molecules. Well, molecules are constantly in motion, so even after they attach, then they just kind of keep floating throughout the glass. And what happens is, over time, it would actually dissolve that entire substance. Sorry. Now you can speed up the rate of dissolution, dissolution, I guess. Ripley! By stirring it to get the molecules going faster, or by applying heat, because heat is energy and heat will cause the molecules to move faster as well. When the molecules move faster, it increases the likelihood that the water molecules will bump into and form hydrogen bonds with the sugar or whatever solute you're using, and thus allow them to separate them. So partial charges, like we said, in water molecules help to dissolve ionic compounds like salt, because remember when we talked about ionic bonding, we mentioned salt, NaCl, and those molecules do have charges and thus can be charged or attracted to the partial charges on a polar molecule or other polar molecules. So lots of different things going on. Phases of water. Like we said, water being made of matter can experience all the phases. So, three main ones that we talk about: gas, liquid, solid. most people, when we think of water, as in, the term water, we think of liquid. But if you heat it up, what happens? It bubbles, it boils, and it turns into steam. Steam is just water vapor, which is essentially gaseous water. But we can also cool it down. And when we cool it down, then we are taking the heat out of it, and it causes it to solidify into ice. Ice is simply solid water. Now, the interesting thing about when water changes its phases, specifically from a liquid to a solid, is what happens in terms of density. Now, normally, when most substances go from a liquid state to a solid state, and that means you have to bring the temperature down. This causes it to lose energy. So typically what happens is the molecules of that substance will get closer together. So typically what will occur is the solid will end up being more dense than it was as a liquid. So if I have some gold and I melt it down, because maybe I want to make some jewelry. When I apply an incredible amount of heat, you can actually melt down gold and have it as a liquid. Now that liquid has a lot of energy in it because of the heat, and the molecules spread out, which is what allows it to be a liquid. But then when I put it in a mold or a shape or whatnot, and I cool it down, then the heat leaves it, which means energy is leaving it, and the molecules of the gold actually get closer and closer together and form a denser solid. But water doesn't do that. Water is actually very unique, because what happens is, instead of the molecules getting closer together when you heat or when you freeze it, the molecules actually push away from each other. This is why ice expands. If you've ever put a full bottle of water in the freezer, you come back to it, the bottle is busted. The ice is actually expanded and will break the bottle, because when you take the energy out of it, when you cool it down, instead of the molecules getting closer together, they push each other apart. Now, since they're further apart than when they were in a liquid state, this actually means that ice is less dense than water. And that's actually why ice floats. We see our poor little polar bear on this little tiny floating chunk of ice. Why, when you put ice into a cup of water, why it floats on top? It's because it's less dense, because as you froze it, the molecules pushed each other away, and this led to it becoming less dense. All right, see, that was relatively painless for this one. Now, just gonna kind of sort of discuss the videos. Again, I'm not gonna watch the videos during this screening, but I will post the link for this Prezi into the description of the video so you can have access to these additional resources. There is only one Science in Pajamas video on properties of water, but it is a little bit longer. I apologize, but I also do some demonstrations about water in there, so it does kind of help. You're not gonna let me do that, are you? All right, so we have lots of demonstrations in there to show the different aspects. All right, so we'll just zoom out for this part. This is being a little silly. I do have some other videos though, of course, that you can see. So we have an Amoeba Sisters video on the properties of water. I love the Amoeba Sisters. They do a very good job of breaking things down and explaining them while still being cutesy. There is a TED Talk, an educational one, so TED Ed, and that talks about how polarity makes water behave strangely. So kind of, again, discusses some of the properties. And a group called What's Up Dude, talking about the structure of water molecule, and it discusses structure, the properties of water, as well as composition. Those would be some good ones to check out in the meantime if you have any other additional questions. definitely hit me up in our Google Classroom or email. But in the meantime, you guys, continue being awesome, all right? All right, so stay safe, stay healthy, and just keep being you. All right, you guys, take care. Until next time, bye-bye.